Greetings, friends. My name is John Gabriel, and this is the New Calculus channel. Excuse me. So today, I want to elaborate a little further on my geometric theorem. Okay, so in other words, try to make it a little simpler so that more people can understand it, and especially those who are math teachers and professors of mathematics. So although I know most of you do not like me or what I advocate, I actually would like you to understand what I'm saying. So I'm going to try and explain it as simply as I can, given the context of everything that has been going on in the past. So let's begin. Now since Newton and Leibniz, there have been many problems understanding calculus and why it works. And so just an interesting little note from Judith Grabiner, who wrote The Origins of Calculus, Rigorous Calculus, of the Origins of Cauchy's Rigorous Calculus. Of course, there was nothing rigorous about it, and she didn't know, and nobody could really blame her for not knowing. But in any case, here is what she says. She says calculus in 1800 was in a curious state. So this is almost 200 years after Newton and Leibniz. There was no doubt that it was correct. Mathematicians of sufficient skill and insight had been successful with it for a century. Okay, so yet no one, pay attention now, yet no one could explain clearly why it worked. To be sure, experts would probably have agreed that some notion of limit lay behind derivatives. Now, that's where the problem comes in, because you don't need limits for either derivatives or integrals. Okay, that's just nonsense. And of course, integrals were defined as antiderivatives and thus raised no separate questions. Okay, so it says, but the discussions of the foundational issues had been desultory and inconclusive. All right, so I'm not going to waste time on Judith Grabiner's nonsense. She's right in this first paragraph, but the rest of the book is, frankly, just a load of poppycock. So now let's go back to what Norman Wilberger said in his video, and I'll place a link to this video so that you can see what it is. So he's discussing this. He's discussing calculus and the history of calculus, and this is a particularly good video because he talks about Bishop Berkeley's remarks and how he mocked Newton. So Newton did something like this. He took a binomial, expanded it, and then he simply said that all these terms that you see here suddenly vanish or disappear. Okay, so that's of course not true, and I'm going to show you shortly again why my historic theorem proves that Newton was right. Not that they vanish. He was right that this is the derivative, but he didn't really know why, and nobody else after him knew why, until I came along. In fact, not a single person understood why calculus actually works. And it has nothing to do with limits, by the way. Limits are not the reason calculus works, and they're not required at all in mathematics or in calculus. Okay? So now, why is this expression that is left over here from the binomial the same as q of xh in my identity? Well, you see, this identity that you see here is proved by my theorem. Okay, so, and in this document here, I actually prove it to you geometrically. Okay, I'll show you. It's quite an interesting document, and to see the geometric proof, you need to read it. So it starts over here, okay? And it shows you that the terms in x are the derivative, and the terms in h are, if there are any, like for example in a straight line there is no term in h, but if there are any terms in h, those terms are the difference between the slope of the tangent line and the non-parallel secant line. Okay, so they got all sidetracked by limits because they were, doing things like this. They were playing around, experimenting to see if they could get close to the tangent slope Okay, so for example, this here gives you the tangent slope for any h because of the identity. It doesn't change. Okay, this here is the correct value because this formula here that I showed you is the correct formula. Okay, that formula there. That's a result of my identity. No one after, in fact, no human before I came along knew of this formula. Now, sometimes this Q of xh is hard to find. In fact, for any transcendental function or any more complicated function, it might not even be possible to find exactly because it's either a series or something else. All right? So what is so important about this? Well, the important thing about this is that it also leads to a seamless formulation for the integral. Okay, so if you read this document, which I'll place a link to here, I show you how you can actually define the integral directly in terms of it. Okay, and that's what I do here, and I give you some examples. So here is the definition of the integral. Okay, this here is the fundamental theorem of calculus. And you can understand it, but you need to spend some time studying it. Okay, so now this knowledge is not worth one Abel Prize alone. It's worth 10 Abel Prizes. Nobody before me realized these things. By the way, this here is an exact formula. It doesn't have any limits in it or anything like that. This says that the slope of the non-parallel secant line is equal to the tangent line slope plus some difference. Okay, now if it's a straight line, there is no difference. There is no Q of xh. It's just the slope of the tangent line of the straight line, right? Because don't be fooled by f prime of x. That just means the slope of the tangent line. So coming back to what Wilberger was saying here this is one of his better videos. He's quite right. Bishop Berkeley had a point, and if I were around in the time of Newton, Newton would have worshipped me. So would have Leibniz, because I knew the answers. I knew why you could discard this expression here. And the answer is very simple from looking at my formula. This Q of xh is, the expression in Q of xh is just the difference. We're not interested in the difference, okay? The difference always has an h in it, or doesn't exist if it's a straight line, okay? And I proved also that the expression in x, in this very document that you're looking at, is the slope of the tangent line or the derivative, okay? So, I mean, I don't know how much simpler than that it can get. I don't know why there is so much animosity to this. And by the way, this here produces exactly the same results as your mainstream calculus, right? And it's simple. And it will also give you a derivative at a point of inflection, which in the new calculus, that's not possible because the new calculus is 100% rigorous. But this is based on Newton's kludgy experiments with trying to evaluate the slope of the tangent line by simply altering the value of h. Okay, but in reality, h doesn't really alter. I mean, the formula is true even if h is 5.5. This formula will still give you the derivative even if h is 5.5. Do you see that? And it's not a tautology or tautologia as you hear many in the mainstream say, because it's not evident. If it were evident, somebody would have realized it before me. There would have been a new calculus long before me. So I am blowing my own trumpet here. But why am I blowing it? Because nobody else will blow it if I don't blow it. Okay? I am worth 10 Abel Prizes. And what you've seen here, people, I'm being very frank with you, is just the tip of what I've discovered. It's so superficial compared to everything else that I know and that I might have been prepared to show if I'm recognized. By the way, recognition to me is awarding me with a great prize in money so that I don't have to worry about being homeless again. Okay? I really mean that, by the way. It's probably not going to happen, but that's the reason I'm not going to share the rest of my knowledge. What incentive is there to share the rest of my knowledge? I am not a fool, and I've shared much more than anyone else has in the history of humanity. I've even given you a free ebook. But what have I gotten in return? I've gotten poverty, I've gotten homelessness, I can't get a job because of all the libel and the slander, to teach even mathematics, not even to earn my own money. So I'm relying currently on welfare, which thankfully there is at this time. Otherwise I wouldn't be able to survive. Well, there you have it, everyone. The greatest people are usually the ones who are persecuted, libeled, and cast aside. I think of Tesla now. I mean, what that man contributed to humanity in physics and science is similar to what I've given to you in mathematics. But look what happened to him. That is the reward for sharing knowledge and trying to make this world a better place. You get labeled a psychopath, a narcissist, you get libeled, people persecute you, and you're hated because you're different from everybody else, because you're good, and everybody else does not understand you, and because they do not understand you, they fear you, they dislike you. Okay. So, okay, and I promised I would tell you more about my life and whatnot, but I'm kind of running out of time now, and I'm out of breath and I'm tired. So perhaps in the next video I'll add another anecdote or two. This is the New Calculus channel. My name is John Gabriel. Till next time, goodbye.